Welcome to another Great Cow Basic tutorial. This tutorial is for the PIC18F Q41 family of chips. I'm going to take you through a whole series of tutorials with respect to this chip over the next few weeks, I guess it will take. So, hi, my name's Evan Venn. I've done this before, and I'll carry on doing this until I'm finished, I guess. Okay, so let's have a look at what the 18F Q41 is. It's a high performance PIC18 microcontroller. It has digital and analog peripherals. It has ADCs. It has SPI, I2C, and SPI communications, pulse width modulation, two different types. We'll look at those, CLCs, and many other features. It comes in different forms, and the ones that I'm specifically looking at are the 18 and the 20 pin small footprint packages, and they help customers who are a bit tight on space. Okay. The videos I'm going to cover are 19 of them, and they cover from making the LED work right the way through to assembler. So they cover ADC, switches, timers, memory, graphics, etc. So I'm trying to cover the whole gamut that's required. So with that, I will go through each one, and the ones we're going to do today are we're going to make an LED flash. Okay, I'm going to be using Great Cow BASIC compiler. It's an open source compiler, and that's available up on the web, and it now supports the 18F Q41 family of chips. So you need to get hold of the software, download it and install it. You need to install your programming software. There are different videos on that. I've got mine installed. And you need to test that it all works and it operates. So download the software. I'll give you the URL in a moment. Download your programming software, make sure it works, and I'm going to do that as part of this. But I'm not going to download the software. I'm going to assume you can do that, and I'm going to assume you can get your programming software operational. So you download the software from SourceForge. We can have a quick look at the SourceForge website just to see where you can download it from. Here we go. Here's the SourceForge website. You take the big download button. The moment you press that, it will then start downloading the software for you. Install it, and then install your programming software of choice. I will be using PICKitPlus. I have a vested interest in that, so I will be using PICKitPlus to ensure that everything is happy. Okay. Back to the slides. I also going to be using a programming board. It's pre-built. I'm going to be using a microchip PICKit2 low pin count demo board. You could alternatively build your own. I'm going to show you how to do that, but you could use one of the pre-built ones for microchip, like the red one, which is a Curiosity nano board. By the time I get to the end of this video, hopefully I'll have some demonstration devices from microchip. Okay, so let's have a look at one of those, shall we? Well, look, here we go. I've actually got the same board. If you look at the PowerPoint for a moment, on the left there, the green one, it looks remarkably similar to the green one that I've got there. It's the other way around for those, and the LEDs are different. But what I've got is I've got a number of different options. I've got one here. This is for a different. This is a similar one. This is a clone one I've been sent. So, and you just plug them into your programmer, and they work. This has got the LEDs. We're going to get to this quite quickly. This LED demonstration. We're going to create that very quickly. And in a day or two, we'll be doing that. It's not hard to do that. Now, as I said, I'm using a PICKit2 programmer. You could use a PICKit4. You could use a PICKit3. You could use a Northern programmer. You can use a clone. There are many different types of programmers out there. Pick your poison, make your choice, and install it. I'm going to be using a PICKit2. Okay, I've got my little board here. I'm going to reconnect that. And this will be very clear. This chip here is the Q41 chip inserted into the PICKit2 low pin count board, and it works fine. Let me just prove that to you, and we're going to go to my desktop, and I've installed my software. So here we go. That's my desktop. I'll just fire up the PICKit software. Here's the PICKit software here. I am just going to do a discovery to check the communications, and it now says up the top there. I'll see if I can zoom in on that for us. Oh, there we go. I can. I did a tools, selected tools, and then I did a check communications. It read it in and validated the fact that that is a 16Q41. It is installed. I have it plugged in, therefore working. Okay. So let me just erase that. And just erase the device, which is a great place to start, isn't it? Yeah. Okay. So this is what the actual board looks like. You can, therefore, you can build your own. You can build your own by following this layout by Chris Roper, this friend of mine in South Africa. And essentially, we've got 4 LEDs connected to port C.0 to .3. That's .0, .1, .2, .3, and that's important because they're connected via some resistors. And on the screen here, if I just show you very briefly with a pen, ballpoint pen, here we go. The LEDs are connected. This will be C0 through the LED, and then down here to ground, and this goes through to ground here with the 0V, and the same is for the next one. Through the LED, through the resistor, down to ground, and so forth. And it's the same as the board I showed you previously for microchip. So what we're going to do is we're going to turn an LED on, and we're going to set the pin high. So as I said, the LEDs are on RC 0 to 3, and one of these, we're going to drive one of those inputs high by turning it on. Okay. Now these I/O pins can be input high or inputs or outputs on startup, so we just need to make sure that we set them correctly. We want a digital output, so we're going to turn it to set its direction to out, and then we're going to turn it on. Very simple. Okay, so in the workshop, we're going to assume that you've got your hardware working, you've got your software installed, you've made your board work because you've done that test in terms of you can find the chip. Let's just make these LEDs work, shall we? Okay. So I'm just going to power up the software. This is Great Cow BASIC. When you install it straight away, it will install it, and it will install it and open it up automatically for you, which is wonderful. Okay. I'm just clicking away here to get you into my desktop. There we go. Where's my desktop? There we go. We're actually in the editor. It will look more like that when you start. So let me just go around and I'll zoom in and just walk you through a number of the interfaces in there for us. So let's just zoom in on there. And what we've got is a dialog area where we type our code. If we have a tree list in here, it will be on the left here, and down the bottom some information when we program. And what we need to do is just put some basic commands into here. And then we'll do that. I'll talk us through that, and then we'll just set the whole machine up. Okay. So here we go. You need to do a couple of things in Great Cow BASIC. You need to set the chip. So that's with hash chip. Tell it what chip it is. Well, we know it's a 16F Q41, so we type in 18F16Q41. You don't need to worry about the frequency, the configuration. We're going to look into that later on to see what happens in the assembler, but that is handled for you, and we'll see that when we compile the program. You might want to put option explicit in, hash option explicit. It just checks your variables. It's good practice. All the green stuff are comments, okay? And you can read those in your leisure, because I'm looking at a demonstration and they're in the demonstration folder for this chip. So I've opened it up and it's sitting there. And we can, as we move through the week, we'll open up those demonstrations. And then the third line of our code, we're going to set the port to out because we need it to be an output, and then set it high by setting it to number 1 because it's a binary port. It's 0 is off and 1 is on, and then I tell it it's the end of the program. Now, a couple of things I just need to do just to set it up. I do need to set up the programmer, and I do that by selecting the word Great Cow BASIC, edit programmer preferences, and just ensure that my chosen programmer, remember my chosen programmer could be any of the ones that we've seen before. It could be a PICKit4, through all those ones I spoke to you about. Just make sure it's at the top. Mine is at the top, so I'm happy. And then I'm just going to make hex in a moment. Press the green and yellow make hex. So I'm going to see if I can zoom on, get my desktop working. See if I get the camera working. Oh, there we go. There's the full program. We can now see it zoomed in. There we go. Great. Wonderful. So what I'm going to do now is I'm going to press the make hex button. You can do it another way, or by pressing function key F5. So I'm going to push function key F5. I will hide the PICKit because we don't really need that on our desktop. Great. And I'm going to press function key F5, and it will bring up a dialog box and it will program it. And you'll see there the LED has now come on. This LED is now on. So we've connected up the PICKit, put the chip in, we've made port 0, C0 come on. How do I know that's the case? Because if I go into PICKit software, remember I hit it a moment ago, I can turn the power off. I'm using the PICKit to power. I can control it by clicking the on and off. So we have a method of actually programming the this particular chip. Very simple. Let's look at another demonstration. Number 20, which is number 2, which is essentially going to flash the chip for us, flash the LED for us. And in the program, I'll just minimize that for us so we can see the whole program. Here it is. We've selected the chip with a hash chip line, specified option explicit. As before, we've set it the direction is out, and all I'm going to do is wait for 1 second and then set it to 0. That port is port C.0 to 0. Wait 1 second and then set it to 1. If I now program that, we'll see this LED on my right start flashing every 1 second. Wonderful. Let's have a look at something we can see on the screen whilst we're in here. We can see that we're getting a little report down the bottom here, and if I can zoom in on that for us, and if we zoom in a bit further would be nice, wouldn't it really? But that will have to do for us today. I'll come back out. It says we've used up 73 words of the memory. We've used no RAM, and by default the compiler has chosen the 64 megahertz internal oscillator, and we can control the oscillator speed by putting a comma and then the speed we design for. If we want 1 megahertz, we press what, put 1 in there. I'll recompile that for us. It will then program it, and the compiler handles the timing for you, so it's still a 1 second pulse, but now we're running the clock of the chip at 1 megahertz. Let's look at another program. This program is similar header. It's got the chip line option explicit, so let's not worry about that too much, but I'm introducing the concept of a constant. So port C0 is now being referred to with a constant, and that is constantly available throughout my program as LED1, and we're going to be using LED1 quite a lot, and other LED and other constants throughout the tutorials. And I've said the direction, the direction of the LED1 is out, and down here I've got a little loop that says a do loop. Wait for 1000 milliseconds, which is the same as 1 second, and I've said LED1, the constant, which refers to port C.0, is not, an exclamation mark. I could type in the word not, or I can use the shorthand exclamation mark, not LED1. And now my code is shorter. I can program it. And we're now 66 words used. Previously, what were we before? Who can remember? 72. With this one, recompile. I've used 1 byte of RAM, but my program is slightly smaller. And if you look out here on the LED, it is flashing for us. Well, we're going to work through this type of process over the next few days, and we're going to work through to a program where it actually flashes the LEDs. So I'm just going to take this demonstration here. It was compiled for a different chip, and I'm just going to change my chip. And program it. It'd be handy if I typed it in correctly. Oh, I'm so sorry. Wonderful. We've now got 4 LEDs flashing, but we're going to come back to that in a few days' time. Let's go back to PowerPoint for a second. So our job there was to make the 3 LEDs flash. I think we've done that today. We've done that, and tomorrow we will come back to the demonstrations, and we're going to make those 4 LEDs flash in a sequence, number 2. And if we've got time, we may even make it look at making 4 LEDs flash in sequence. But this is a Great Cow BASIC tutorial for the Q41 chipset. Enjoy.